Personally, I prefer to use Bloc because Bloc is simple and easy to understand. It's really predictable because you handle your state by sending events and updating in a single place. Also, it is scalable because you can even have different blocks, one for handling the cart, one for handling the user, and most important is testable. We discovered today, thanks to Teresa Wu, how much is important to having your app testable. Welcome to my talk about From Zero to App with Bloc. I would like to show you how you can handle the state of your application in a simple way by using this package. When you create an application, many things go around. For example, if you imagine a cart application, by the way, this is a GIF taken from the documentation that I like really much. You can see how many widgets should work together in order to have your application behave correctly. For example, in a shop application, you have your cart, you have your list of items that you can purchase, you have a detailed view, then you can check before making the actual checkout, and many things around. Maybe even a login screen. So this is the application that I want to show you how I handled. We will have the login screen, the first, the screen where you manage your purchase with a badge to indicate how many purchases you have, and a final screen where you can check out, remove some items, and finally finalize the purchase. I won't go into detail of how you should build this screen because for the UI you may vary a lot, but I will go into detail about the logic. For example, the item for the shop item can be simply a class that contains the ID, the name, the price, and so on. Everything you need to be shown on a single list tile. It's the widget I used for this line. Then we have a cart item where we need to understand how much of a single item we have, for example, to sum up the total count of the application. And finally, a cart model where we have a list of the items contained in order to have the whole purchase available to the user and show the list of it, and some method that let the user modify this kind of model. For example, we may want to add an item, remove an item, or just reduce the quantity. Why this method is returning a cart, we will see that later. And some commodity methods for example, get the total price for the cart, get the quantity of just an item, and so on. This will be our main model where we work on. What's happened when we click somewhere? Basically, if we use that in a common way, we will surely have a stateful widget. We will need to init the state with an empty cart. On top, on a plus, minus, or on the cart or somewhere else, we need to call a set state. And when we tap on the cart, we need to navigate on the checkout screen. And then, of course, if we make any change on the checkout screen and we get back, we need on the first screen to await the result of the pop to see if we should make again a set state and update again the cart. This looks simple, but what's happened if I click on the cart, I go and send the cart item, the cart model to the other screen, I go back, I go modify, I have again to send the new cart model to the next screen. If I change something, there is a lot of going back and forth every time I call a set state. It's simple, but maybe we are updating our UI too much. How we can solve this? Personally, I prefer to use Bloc. Why I use Bloc? Because Bloc is simple and easy to understand. It's really predictable because you handle your state by sending events and updating in a single place. Also, it is scalable because you can even have different blocks, one for handling the cart, one for handling the user, and so on. And most important is testable. We discovered today, thanks to Teresa Wu, how much is important to having your app testable. So this is more or less the structure of an application with Bloc. Basically, you have several components that work together in order to have your application being organized and updating the state accordingly. Let's see one by one. First of all, if you want to use Bloc, you need to add it to your dependencies. The fastest way is to just call in the command line interface the Flutter pub add, Flutter block, and it will add the latest version. Or you can manually add to the pubspec.yaml the version you intend to use. In this case, the one I saw yesterday when I finished the slide, it was the 8.12, but it can change over the time, of course. Then let's see the main part of the Bloc library, the Bloc class. It's a class that accepts events and as input and will yield, or better, emit now, new state based on what happened on the event. Let's see the anatomy of this class. As you see, we have a cart block class. The name is what I use it to call. That should extend Bloc. Bloc with two parameters. The first one is the type of your event. In this case, I created a class called cart event, and inside the initializer, you can have the on cart event, and you have also a function with the event and the emitter to handle that. And a state. Do you notice that? I'm using my cart as a state. What we need to do in response of an event in the on method, we need to emit a new state. In this case, I'm just emitting an empty cart just for showing the code. So, do you remember the cart class I showed to you before? That is what we need to send in the event, in the state. Because basically, the state can be anything, and I'm just passing it to the block. Let's talk about the event. The event is basically the bridge between what's happening on the UI, what the user do, and what the block should do. For example, if the user taps on a button, the event can be fired. We should add the event to the block, and this will make something happen inside of our class. The event class can be anything. I created just an empty cart event class. Why I created that? Because do you remember the method that I put inside the cart? Instead of using the method, I will use the class. Basically, for each one of the method, I created a corresponding class that extends the cart event and will do what we need to do. Of course, we can also add some parameters to the constructor. For example, in the add item event, we may need the actual item I want to remove. The same for the other. Now I have a cart event class that is the main parent class for everything, and another class that extends that with a specialized name that I will use to do the following. Do you remember that in the block I had the on cart event? Now I can do an on method for each one of the class I created. This way, as I said, it will be really predictable because anytime I fire an event, I add the event to the block, I will know what is the outcome. What the outcome should do. We, after receive the event will be processed by the block class inside the on method. We need to emit a state. So when we add the new cart, in this case, we need to emit a new state based on what happened on the event. The method I created, it returns a new cart. This can be useful because we can use directly those methods in the on and create something like this. For each one of the event I have, for example, when I add item event, on add item event, I emit the current state. The state is a variable that you have inside of the block class, and is the current state. In this case, is a cart because we are defined the cart as a state for our block. And I call the add item. This way, I can return a new instance of the cart as a new state. Because remember, the emit won't emit twice the same state. So it's better to copy or use some other methods because, for example, you can use equatable. Because if you emit twice the same state, your block won't emit anything, actually. Of course, I have the on for the other event, the reduce item, and the remove item. What's happened when we do something? Imagine that I tap on the button for adding a product. I launch the add item event. It will be received from the block on the on method, and I will have the event and the emitter. So I know that an item was added. I call the emit of the new state adding said item, and the state will be emitted, ready to the UI to be updated. To update the UI, we must use some components. We have several things that we can use either to update the UI, listen for the events, and provide the blocks. Let's see one by one. First of all, build the UI. When we want to update this line, we can wrap this line, or better, we can wrap that counter with a block builder. Usually we have, in the classic approach, we have the text and we read the current state. For example, we have the cart in our stateful widget and we get the item quantity. It's more or less the same, but we wrap our widget with a block builder. The block builder will update every time the value on the block change, the state on the block change, and it will update our UI. But why I want to add a lot of code? Because I need to wrap my text in a block builder, and I have to use a block with the event, whatever, all the things we saw, if I can just use the set state. When I tap on the add button, imagine that I call the set state to update that line. What's happening is that the whole widget where I call the set state get updated, get rebuilded. With the block builder, I have only the widget influenced by the block builder, call its rebuild method. This way, instead of rebuilding the whole page, I will just rebuild the influenced widget. So in this case, the badge, the values, and the cart. But there is more, because if I update, say, the quantity, I don't want to update all the quantity. I don't want to rebuild all of those. What can I do? Add a build when. The build when is another parameter of the block builder that let me specify when the builder should be called. In this case, I can check the previous state and the current state, do the comparison, and update that specific text only when the quantity for that specific line is updated. This way, if I tap on the add button, actually only that text, the badge, and the bottom with the total price will be updated. Now, let's see how to send the event. To send the event, usually in the common way, we use the set state when we press on the button, and we saw that we want to get rid of that. More or less, we do the same. The only thing that changed, instead of calling the set state, we call the add method of my instance of block. This way, we can add a cart event instance. Since add item event will add the actual item, we can use that because it is extending that. Now, we may have a question, how we can provide the block to our widget tree. The simplest way, but probably you will never use that, is in your block builder, you add your instance. So you create your block in the same widget, you provide it, and it will work. But this approach, more or less, is like the approach that you can have with the set, so maybe we can do something better. Instead of using that, we can use the block provider. The block provider is a widget that you can use to provide all the widget below your block provider, the instance you need. For example, since we need the cart model to be shared between two screens, I can wrap my material app with a block provider of the type of the widget we need, the block we need. So, block provider of cart block, and we have the create method where we provide the new instance. This will be called the first time only, it will be created, and the child. This way, by using the provider, every widget that is under our cart block will receive any update on it. And we can use the block provider of context or context.read to get to the nearest instance of it. Of course, only the widget under our block provider will get the updates, not widgets that are under another branch of our tree. In this case, what it changed? We have our button. Instead of using the instance, we use the method context.read to pick the nearest block instance of the block type that I need. So in this case, I think, okay, don't worry. Getting back, okay. Instead of this line that you see with many code on it, basically you have context.read square bracket, the type of the block, and then you have the add like before. This way, you can get the nearest instance. What happened in this case? Imagine that you have the elevated button where you make your method call. You tap, the block provider or the context read will go up to the widget tree to get the first available instance. It will add the event to the first available instance of your block, and it will emit a new state that will be read for all the widgets that we have inside of the tree. Of course, the other branch is still excluded. So now I want to show you something different, because since now we have seen how to build your UI, but sometimes we need also to just listen to some change. For this, let's see how the login page works now. Before that, we can just create another block, because as I said, we can scale. I don't advise you to use a monolith block for everything. Just make it specialized, because the less information you have inside a block, the less you have to manage the build when and so on. For example, I don't want to care on my quantity text if the user is authenticated or not. So I separate the two widgets, the two blocks, in order to have one that manages the cart, and only the widget that needs the cart will listen to that, and one for the authentication. This way, like we did before, we have our block type of event and state, in this case, out event, out state, and our own method. Then the state. This time I did something different. It's up to you. You can handle that by reading the parameters inside the state, or you can create several states that extends your original state in order to check what is changed. This, for example, was more useful to me for the login page, because I wanted to change the UI while something else was in loading, and I also wanted to listen to some event to navigate away. And then our event. In this case, I needed only the login event, so maybe extending the out event wasn't even necessarily, but I can foresee that you may need logout, because yes, we want to retain user, but not by force, please. And how to provide it. You can nest a block provider inside another block provider. You can do that? Yes. There is a better way? Yes. You can use a multi-block provider that will have the provider's parameters, provider's parameters, where you can provide your array of block provider. So one for the cart block, one for the out block. In this case, anyone inside the material application will be able to read both of those. Remember that in this case, it's okay, because the cart block and the out block needs to be outside or over the material application, because you need it across several screens. But you should always think about putting that on the lowest branch possible, because you don't need, for example, a block that manages a single screen being shared across across the whole application. Okay, so Now that I have my block in place, let's see what I do on the login event. This time, we do something different. We need to recover some data from somewhere else, because if I make the login, I need to make an API call, probably, and wait for the result. The first thing I do is to emit a login in progress state. Anyone listening knows that it is not anymore in the idle state. Something is happening. For example, I can use this to disable the login button, or in this case, to hide it completely. Then we need to await the actual login call to understand what is happening, emit a new state based on what happened, because we can have a success login, so the success login state, or an error. We check the success, we emit a cordling, and then after that, I want to get to a neutral state. I emit those in order. I know for sure that these will be emitted in this order I use. Then, in the button, I can use my builder to hide the actual button and show a progress indicator. This way, if the state is not in the idle state, I show the loading button, the loading indicator. There is no way for the user to tap the button that doesn't exist. And I add something different. Above my scaffold, or really about where we want to add that, I can add a block listener. A block listener is a different widget that we can use in the UI to listen for the event, for the new state. We have the child. The child this time won't be rebuilded based on the outcome of the state. So even if I emit a new state, the child will stay the same. We won't rebuild the state, and we don't need that. The button will be rebuilt on its own because it's around a block builder, but not the whole page. And then we have the listener. The listener will be triggered every time the state is updated. In this case, what I want to do is that if I have a login such as state, I want to navigate to the shopping page. This way, seamlessly, I can tap on the login page, on the login button, have the login state, and only in case of success, I navigate to the next page. In case of error, maybe I can show a message like a scaffold, wrong credential. But what is important is that the successive state will be the idle state. So the button will reappear. Of course, this is a login without any kind of credential, so I don't know how you can get your password wrong, but that's fine. So let's see what are some issues that you can handle when you use block. The most important one, the block builder or listener, it's not a child of the type of block you are checking. When I use the block builder, for example, and I don't pass a block instance as a parameters, it expects upper in the tree to have a block provider of that type. If not, you get an error. Same for the block listener, and same for any time I call the context.read for a type of a block. It expects to find a block type of your type, requested type, over on the widget tree. If not, you have an error. As I said, the same state is never yelled twice. Most common case, You update a list, you return the same list, you expect it to update, it doesn't happen because it's the same instance. So you need to most probably copy the list or use a more complex class where you can implement the equality check. My suggestion is to use an equatable package that easily give you a way to check the equality of two instances. Nested widget can cause some issue because if you have two block providers nested, remember that you see only the nearest one. So it can get obfuscated from the nested one, and you need to act accordingly. Most probably, if you have two block providers of the same type in the same branch, something sometimes can be a problem in the architecture of the code. So you may not want to have this kind of situation. And then, if you have nested builders of the same type, remember that the second one, the lowest one, will basically ignore is build when, because the topmost one will rebuild, and of course you will rebuild even the second, even if your build when return false. That's all for me. Thank you. If you want to talk with me, you will find me around during the conference, and I will give you some stickers for Flutter Italia. If you have any question, I'm here.
Thank you, Carlo.